the video at the address seen on the screen, showing difference in work a magnetic sphere does when approaching a magnet from infinity from different directions, caused some to suggest that the effect may be due to eddy currents. The experiment presented here proves, however, that the effect observed is real, and this leads to the violation of conservation of energy. Here we use the same round magnet, pointed by the green laser spot, and will measure the force the magnetic sphere experiences at different distances from the minimum of the magnetic potential energy. For convenience, we enclose the magnetic sphere in a plastic pill box and measure the force by attaching it to a handheld scale. As you can see, the measurement in this disposition of the magnet is by moving the magnetic sphere axially. The tangential motion is measured by positioning the magnet flat, not shown in this video. We then plot the value of the force, averaged over 10 different measurements for each point, as a function of the distance at which the magnetic sphere is removed from the minimum of the magnetic potential energy. What we see is shocking indeed. The area under the force distance curve corresponding to the axial removal is obviously greater than the area under the tangential curve. When removing the magnet sphere from the minimum of the magnetic potential energy to practically infinity, that is, where the force of the magnet on the magnet sphere practically disappears, one can, redundantly, do this integration numerically, and even have Wolfram Alpha or Mathematica integrate the function fitted to the data obtained. The surface area under the observed curves represents the work done on the sphere. We can, however, remove the sphere tangentially, bring it to infinity, and then let it spontaneously go along an axial route towards the minimum magnetic potential energy. Bringing the sphere from one place to another, at practically infinite distance from the magnet, requires doing of no work. In this way, we can keep pulling the sphere along the route requiring less energy to bring it to infinity. Move, at no expense, the sphere at infinity to the appropriate place, where when let go, it will produce greater energy than the input, and as a result we will have periodic production of energy for which we have done no work and which doesn't come from a pre-existing energy reservoir. in clear violation of conservation of energy.